In this example, we're going to show how you can use RStudio to perform a t-test on the slope for a simple linear regression analysis. A computer manager needs to know how efficiency of her new computer program depends on the size of incoming data, and efficiency will be measured by the number of processed requests per hour. So the response variable here is the number of processed requests. This is going to be defined as y, and the explanatory variable is the data size in gigabytes. So we want to perform a t-test on the slope using a significance level of 0.05. So the first thing that we need to do is we need to run in our data x and y, and then we need to run a linear model. So lm is the command, y is the response variable, x is the explanatory variable, and I'm going to call it mod. Then I'm going to take a summary of that so I can get some nice output. Now, if I look at my output, I can see my estimate for the slope of my line and the intercept. And then along this entire line, I will find information about my explanatory variable. So my estimate, my standard error, the t-critical value from the t-test on the slope, and the associated p-value. So just in general, this t-critical value is quite large. Negative 7.32 is a big t-critical value for any type of t-procedure. So it would imply that our p-value would be very small, which it is. Basically, it is 0.000004. I might have added a couple zeros in there, but it's really significant. It's a really small p-value. So what this means is that there is convincing evidence that the size of the data is a significant predictor of processed requests. So the size of the data is a significant predictor for processed requests, which means it does a good job explaining the variation or explaining the change in our response variable processed requests. So we can reject the null hypothesis that basically the slope is equal to 0 because there is just no evidence of that. So there is convincing evidence that the slope is actually something other than 0 and that x does a good job of explaining the change in y. Just as a side note, the degrees of freedom that are always associated with our test are the same as the residual degrees of freedom. So that's 9 degrees of freedom, and it's right here in our output.